So hi everyone, morning, afternoon, evening. Thank you again for joining us on this webinar, and thank you again for joining this second part of the automation and customization in this 2024 series. In the first one, last week, we went over the more kind of bigger picture and the wider update on the topic of automation customization. And today the aim is to dive a bit more into details of Python API. Specifically, we will start with HyperMesh client APIs, how Python is shaped for HyperMesh, how it looks there, and how to work with it. And then I will hand it over to Stefan, who will cover HyperView and HyperGraph. As you probably know, the first instance was already introduced in 2023.1. So here in today's session, we'll mostly focus on updates and new features. And we'll close today's sessions with an update from Dimitri on Altair community and our plans with respect to that. Let me start with HyperMesh client Python API then. Some of you might be familiar with this slide, which I have presented in the past, but I think it's a really good start to compare, the world of TCL and the world of Python. For those of you who are jumping straight into Python, you might not be too excited about the past from that perspective and what has been happening in TCL, but also from that perspective, I think you and I hope you will find it useful in a sense that it will give you a background story behind how Python APIs are shaped today. And as we discussed a few times in the past, the current shape is an intermediate stage. We're planning to build on top of it and expand the, let's say, the dimension of object-oriented API and improve it further. Okay. So the basics. In TCL, we're talking typically about entity types, entities, data names, entity mark for selecting entities, and last but not least, the modify and query commands. So transferring this into the Python world, in Python, we'll be talking about entity classes when it comes to entities. So, element class, property class, material class, and so on. The entities themselves, while in TCL, we typically refer to them through IDs. In Python, we'll be talking about objects. Wherever we could, we really try to focus on that object-oriented nature of Python and try to take advantage of it and bring some nice goodies, some nice functionalities and features based on that to the user. Consequently, if we treat entities as objects, we can then treat their data names as attributes of those objects. Instead of working with marks, in Python, we are working with collections. This means that you can create the collection object at the start of your script and carry on using it throughout. It's a persistent object. You don't have to work with marks, kind of clear marks, create mark, populate mark, etc. And last but not least, the functions or the services, as we refer to them in the Python context of HyperMesh, are all accessible as model instance methods. And I will show a bit more details on this in a live demo in a few minutes. Going back to the webinar from last week, we spoke about how we organized the project of Python API and what we actually worked on to bring this to you. And we organized the API into 5 categories. We can see on this slide. And we said that really the core, the main focus was around collection, database, and services. What I maybe didn't make that clear in last week's webinar is that all the functionalities are available in Python API as of 2024.0, with obviously the plan to increase the coverage. I think I showed the slide that give you an idea how many commands are supported. We're around 95% of the coverage there. So obviously in the subsequent releases, we are aiming to cover everything at 100%. Now, what I would like to show you here is just to give you a brief idea where you can find each components from the perspective of Python modules. Again, things are organized slightly differently in Python if you're coming from the TCL world. So I want to highlight these for both existing TCL users migrating to Python as well as completely new users to automation customization who were eagerly waiting for Python API to be available. So starting with the GUI at the top, if you are planning to customize GUI, create custom dialogues, custom messages, features, all of it is available in the hwx.gui module. And if you remember from last week, we highlighted the fact that this module is available across all our applications that share the same framework. So that is Altair Simulab, Altair Inspire, Altair Compose, and of course Altair HyperMesh. They're all based on the same platform. Hence, if you're using this module to create custom GUIs, you can transfer your custom GUIs to any of these applications, and the knowledge of these APIs is transferable. Collections. Here we need to create a collection object. If you think about the workflows in the interactive world, you're getting into a context and you're selecting the entities you want to work with. In the API world, this means creating a collection object. Collection class sits in the agent module. So from there, this is your starting point to create a collection, whether it's a collection of elements, nodes, parts, etc. Moving to database, this is the second module that you will need when you work with Python API, and this is the agent.entities module. Okay, this module groups all the entity classes. As I said, nodes, elements, properties, materials, parts, whichever. All of them sit in this module. You need to import this module to get access to these classes. And really, I guess the highlight, the agent services, as we call them in the Python project, they are accessible sort of from within the agent module, but specifically they are available on your model object, on your model instance as instance methods. Okay, so if you're working with a specific model, you need to grab the handle on it and then work with it through the services. Here, as a quick kind of snippet, we're seeing the usage of show entity API. Okay, that's available on the model. So any standard commands, and again, this information is also interesting for users moving from TCL to Python. This is where things are looking very similar to TCL. This is where things are, let's say, a very procedural. These commands are converted or brought to Python in a very one-to-one fashion, let's say, with TCL. So anyone with TCL knowledge can surely leverage that when moving to Python here. And last but not least, settings. So settings, they have been exposed through well-known set option command in the past, because settings are not necessarily, model dependent, or is not something that you need a model for to work with. Again, linking it back to the interactive world, or the world of GUI, you go to File, Preferences, and you change your preferences, not necessarily with an active model loaded, right? So we wanted to reflect this, and we exposed the necessary functions directly in the HM module. Okay, so they are top-level functions that you can access without having to load the model. So they are separated from the other services available directly on the model. Now, talking a bit more about the services itself, I would like to highlight just a couple of facts, couple of points before jumping into a live demo. So talking about the modified methods, or as we know them, the modified commands in TCL, we made sure that the argument names are in line with the documentation. And there are a few differences or improvements, let's say, in the Python world. In TCL, there are many situations where you need to use sort of helper commands, such as create vector. That's all gone. In Python, we simply rely on specific data types that the user defines as arguments. So the workflow is more streamlined and feels more natural. Also, the signatures of those functions have been simplified to quite some extent. Wherever you see in TCL entity types in a mark ID or an entity ID, thanks to the object-oriented nature, we could just work with a single argument, either a collection object as an example here, or an entity object. Again, just to very quickly link things to the world of TCL, if you look at the translate mark command here. In Python, we've got 3 arguments: collection, a vector ID, and a distance. Okay, looking at the existing documentation, the list of input files, the lists entity type, mark ID, vector ID, and distance. Okay, so you can see in Python, these 2 arguments become one simple collection object. Vector ID does not require a create vector command beforehand. It simply refers to HW triple object. I will explain in a few minutes. It's not always necessary to use the specific data type. We have introduced the implicit conversion in the background, which will be further improved. So in many situations, user can simply supply a native Python data type. And last but not least, a distance, right? That's the same thing. So we're hoping with this approach, again, people new to our automation, API layer in general, they will find all the information necessary in the documentation, but also existing users moving from TCL to Python will find it natural. The other type of commands that do not necessarily modify your model, don't perform changes, but they give you some information. Now we refer to them as query methods, query functions, if you will, and they provide some sort of querying mechanism. Could be anything as simple as you can see on this slide, getting a mass value, or it can be something more complex like a collision check. All in all, these commands do not alter the model. They work with it to provide some extra information. The key information to take away from this slide is that in Python, these commands return two objects, as you can see on the screenshot here, status and result. This result object is what will interest you mostly because it carries the output information from this command. It can be a simple flat result object with a list of attributes that describe the query information, or it can also provide you an entry point to further result objects. The output from a query command can be quite complex. It can be a set of nested information, and that's something that is taken care of by the so-called HGEM result query list object. Again, I'll try to very quickly show it in a live demo. Before we jump into live demo, I thought, again, for the purpose of leaving you with these slides after the webinar, I wanted to kind of highlight certain differences and simply compare TCL script with a Python script. So on the left-hand side, we've got the existing TCL code. It's just a very simple made-up kind of routine where we start with creating a property and defining the thickness of a p-shell property. We then define a material, define the attributes of the new material. Then we assign the material to the property. So this is something that would apply to, for example, OptiStruct solver specifically. Afterwards, we assign this property to the components. We proceed with scaling those components, and after scaling, we get the mass data of all our components. How will this look in Python? So first impression, nothing too crazy. Maybe you will notice slightly less verbose, less text, roughly same number of lines. So let's go through it. We need to start by importing the modules and defining the model handle I mentioned earlier. So these are the specifics for Python API. Obviously, importing modules is a general kind of Python thing, but specifically to our API layer, we need to create the model object. Once we have the model object, things look, fairly similar, and hopefully you can see where that object-oriented aspect steps in and simplifies user's life. So here we're creating new property through the class constructor. We're assigned a card image in a separate step. Logic behind the scene is slightly different, so we need to first create the object and then assign the card image, and then we proceed to defining the p-shell thickness on it. What makes it really interesting is that if you are going through these steps interactively in the console, simply by hitting tab, you will see the list of all attributes that are editable, that are available on that object, which means you don't have to go through other commands to get the list of attributes or go back to the documentation. So in other words, a lot of it is on your fingertip directly in the console. Once you've got the property, we can create the material object. Again, proceed with defining the card image and define all its attributes. Once we've got the material, we can assign it to the property. Again, here you can clearly see that the step is more straightforward comparing to TCL. You simply grab your property object and define the material ID attribute. Again, please excuse these sort of small details, as in we're calling the attribute material ID, but we are referring to an actual object. These are the things we will try to polish in the subsequent releases, and it's the details that we need to put the final touches on. But again, it highlights the object-oriented aspect of Python, where we are not referring to an entity by an ID, by an integer, but we are referring to it by its object. Next step, very similar in both languages, we are creating a group of all components. So in Python, it is a collection. And then on the collection, we are using the setItems method to apply the property to all the components. Next step, scaling the components. Again, very similar to DCL in this sense, because we follow the same core functions, right? They expose the same core functionality. So we're scaling components by 1.25. The obvious advantage here is that I don't have to recreate the mark. I simply refer to the previously created collection object. And one point I want to make here, although it is more verbose to reference an entity by its object, right? So instead of just a simple one as ID1 referring to a node, here I need to create that object. What I personally prefer as a user is that sort of traceability. So looking back at the code, I understand that this is representing a node object. Looking on the left-hand side, you don't necessarily know that this ID1 is actually a node ID. So we're hoping that users will appreciate this change, and certainly, the ability to review the code and understand what's going on more easily. And the last step on these slides, the review of the mass. Again, more straightforward, and as part of the code, you can see directly which information you're dealing with. The res or result object has also an attribute which lists all the available data. So without the need to go back to the documentation, user can see what the result object gives them, and they can easily consume them in the code. So that's it from the PowerPoint. For those of you who have attended last week's webinar, I quickly showed you the extension demo that we will share on the community that Dimitri will talk about at the end of this session. So what I'm going to do now, very quickly, just highlight a few things about that demo, and then if I can still spare a few minutes, I will show a couple of things directly live in the console. So with this Python demos extension, as I said, we'll share it on the community. So once you download it, you can load it through Extensions Manager into your session, and it's just a set of scripts that give you an idea of what can be done with the Python APIs, not just with the APIs that we focused on as part of this project, the HyperGem services, the HyperMesh services as we refer to them, but also shows you the how closely Python API and Python libraries are married to our new user interface. So one of the demos is a Plotly web view. You can create a doc window with a Plotly graph directly embedded there. You can then dock it back into your session. And there's a handful of other demos. I don't know if I clean the session very quickly and close the window and load, for example, the API demo. Now loads the model, creates a table directly in the console. So you can work a bit more with the console in Python than previously. As we mentioned last week, it supports matplotlib as well. And again, a dockable window. So these are really a set of things that you can play with to understand Python APIs a bit better, and also to get a feeling for the capabilities and how far you can push things. And let me close the live demo with few features, few things that I want to highlight here today on the second session with a very simple test model. First of all, I wanted to highlight how you can run a Python script. So either you go through File, Load, and reference a Python script here, or you can use a magic command directly in the console, which if I still have it in the memory, we can execute a little script here, which is the script, by the way, that we saw on the slides. So the script created a property material, defined its properties, then assigned the property to all our components, and last but not least, output the mass, volume, and area information. Okay. As I said, I'm quite a big fan of the console. It helps you access the information in a quite quick way if I very quickly import the necessary modules, just to show you a few features as and then we, for the sake, we'll just call it an M for model. Okay. And then let's say we want to do something like translate, right? So translate mark is our command. If I don't remember all the command arguments, I can use the question mark here, which will output the command signature and give me an idea of all the arguments. By the way, if some arguments are optional and have default values, you can see those default values here in the signature. So quite a lot of information is accessible directly there. One thing I want to highlight here, and this is our plan for the next releases, that is error handling. So a bit of a disclaimer. Currently, if you run your script through file load Python, we do not print the error messages in the Python window. Something we're planning to address. And also, we are planning to improve the error handling through the commands directly. What I mean, let's say we want to translate these elements. So I will create very quickly a collection of elements. So we reference the model, the entity class, and we've got a collection of all these elements. Now, what I haven't mentioned is that even modify functions, they return a status object. Not a query object, that's only for query commands, but status is there. So what I'll do, translate markup, spell it correctly, reference elements, HW triple. This is where the implicit conversion steps in. It is fully documented. We provide a list of which data types are currently converted. As I said, this this list will grow in the next version. So more and more data types will be natively supported through their Python equivalent. HW triple is one of them, which means I do not have to create it. I can simply supply a Python list. So let's say I want to translate things in X direction. So I'll supply a list of 3 doubles, which will define the vector 1, 0, 0. And the last bit, let's make a mistake. Let's translate it by a 0 distance, right? In the future, this will lead to a Python error message. Currently, those messages are captured only through the status object, okay? Something to keep in mind for version 2024.0. You will get the message, and you will also get a non-zero status value on the object, meaning that something went wrong, okay? This is something, as I said, we're planning to address, and from the future versions, you should see as a traditional, let's say, Python error message. Since I'm taking quite a lot of time and I want to make sure that Stefan and Dimitri have enough time for their part, I will close with a very quick demo of the result objects. On the slides, you saw a very simple result query object from a query command, which is a flat one. What I'm going to show you very quickly is a result query list. So let's do the following. Let's run a command that gives us some metadata. Data and all of it. Right, that's it. Now, if we look at the type of our result object here, we can see that it's the query result list. That means that it has a length, and it actually includes 8 other result query objects. If I want to work with the first one, I can treat it as a list. And then on the first one, I can see the keys, all the information that it provides. And if we want to have a look at the name of the data name, it's a component. Color, actually, we can see it here. We've got it on component 9 and 10. If you look at the value, pink, so it's probably coming from this one, right? But I can double check it. If I ask for the entity object and ask for the ID, that's 9, right? I can check the name of it. So this, as a user, I feel, you're gaining a lot of flexibility and sort of more dynamic usage of the API thanks to the object-oriented nature of it. And with this, I will hand it back to Stefan, so we can go through HyperView and HyperGraph updates. I hope this gave you a bit of a teaser of how HyperMesh API looks like in 2024. As I said, there's plenty to cover. We can't treat this session as a training, unfortunately. I would love to talk to you for another hour about this, but I don't think you would like it too much. So let's go into the interesting part of HVHG, and we can discuss further questions afterwards. And of course, as Dimitri will explain, we would like to hear from you on the community as well. So Stefan, over to you. Thank you.
Okay, let's start with HyperView. So we have two important classes, the section and the node class now in 2024. For the node class, we support all of the node properties, as you see here. Most of them supported. For this one, for this demo, I create 4 nodes. I have the node IDs, the font sizes, and colors here in a dictionary, because the color, there were some questions last time I deep dive here, use this to deep dive into colors. The colors are supported at color objects, RGB or hex code. I can use the RGB as a tuple or list and the text color, the hex code as a string directly. If I want to use the legacy IDs from 0 to 63 or 1 to 64, depending on pre and post, I can create a color object and set the color here with the post or pre index, and then use the color object to set the color. For the font size, please note that most likely people only change the size. So we added not only the font object, but also just simply the font size, that you can say, okay, I want to change the size to 24 or so. Before I run the demo, I want to mention that for nodes, the field expression is always a hot topic. What can I use? So the node object here has a method getFieldDictionary, and this one will return all the expressions which you can use depending on the state of the node. So if the node attached, you see obviously more, and that will make the editing much easier. Let's switch to the live demo here. This is the multiple nodes. I run it. We say here the console, the IPython console, and you will see the script runs, nodes are created, and I put here out also the expressions which you can use for this node. Let's go with section cuts. I have here a more complex demo. So for planar and spherical section cut, I will run through place planar section at the maximum of displacement here for magnitude X, Y, Z. And I will do the section cut spherical at the maximum of the stress here for this model. So this is basically my own hotspot finder here. How will this happen? So first I create the section cut here. I show you that you cannot just create the section cut right away, but also add some settings to it. For here you see the classes for planar and spherical. Please be aware, you can just simply section cut planar or spherical, and you get exactly like when you add one in the GUI, all the defaults placed at the center of the model, etc. orientation are exactly the same. So it makes life very easy. All this positioning and orientation methods with nodes, coordinates, etc. are supported here. I use the orientation by axis Y and the max node ID, and for the sphere, the base coordinates. How do I find the element with the max value? I use here an entity filter, operation top N, value 1. And then for the coordinates of the max node, I create a node filter, use a node collection, use the entity filter, and then get the first element, the max node, and then I use from this entity the ID to position my section. And for the sphere, I use the centroid of the element with the max. So again, I use the same filter, make an element collection, get the first one, and then ask the max element for the centroid and use it for base coordinates. I use the frame animation tool to set the frame step for better visuality, and eval HWC, because views are not currently supported in Python, to modify the view for better visualization. I run the script. You see it here, sections. You will see the model is loaded, and one after the other. You see here, I clicked on the HWC console, you see that the Python commands are executed. I haven't turned on the logging for HWC. When you see directly the match in the HWC recording when this runs. Let's move on to HyperGraph. For HyperGraph, we have 5 more big classes. So for complex curve, we have full support, including all the vector attributes. Data file object allows you to look into plot files and get the channel info, the header information. Data file query allows you to get the values in special in Python format. And then we can also plot very easily, similar to the grade by curves panel for single and multiple files. Let's see, complex curves. So for complex class, we have full coverage for all attributes. You see here, in this demo, I plot depending on real and imaginary components. I plot the curves and have here the color list. Please be aware that if you want to switch from XY to complex, set the axis mode, etc., this is all done on the window class. Although deleting of entities is here supported on the window class. Let's go there, and the client switches, the curves are loaded, and then we will see here let's clear for the next demo, and then the curves are plotted and the shading is done according to on the last curve and between the last created object and the second curve. Let's go to the plot file channel info. That allows us to look into the file. So I create the data file object. Mandatory is the plot file. With this, I can get for a selected data type, here for the second one of the data type list, I can get the requesting component. And this one is exactly the one-to-one match which you see if you go to create curves by file and want to see what's here inside. In addition, if you have legacy scripts, very important that you also can handle the reader version. You see, with the data file object, I can ask the reader version and set it. So if you have a legacy script for the punch file reader, it has previous, and you don't want to change it, just use the reader version, change it, and then where you can run the script exactly one-to-one using this one. Okay, and also last not least, metadata is handled. So for each type request component or subcase, you can ask the metadata, the label, and you can modify the value accordingly. So let's run a quick demo. Here for the Python, the next 2 will be a bigger one. So we can query, and you will see the script runs the code and it will be executed. Let's clear again and go to the next. So for the query, now it becomes interesting. You want to get the value in batch without even looking at it in the GUI. So this allows the data file query class. You see above, I have the data file to get the channel information. Again, we have wildcard support. So I have to give the data file query a plot file, and then I need at least type request components from that I know for these values I wanted. And then I can ask the data file query, okay, give me your values in NumPy format, and it will return it. If you include the time, which is by default true, then this will be that the independent vector comes first. You see here 0 to 150 here for this example. The independent vector will be also included. And I have my NumPy array and can do whatever I want to do in NumPy. If I want, I can use exactly the same query command with pandas. Pandas, I get a pandas data frame, and then I can plot the pandas data frame, one-to-one, and all the header information, etc., is automatically included. And there is one disclaimer. For now, we support this only with consistent number of points and sampling rate. So to support different, we would need to have linear interpolation and resampling, etc. Maybe we do this in a later version, but for now, you can quickly get everything from the plot file in NumPy or Pandas and use it as you want. I run this demo, this code, what you have seen here, And you see the NumPy array with the independent vector comes out, and you will see the plotting in the IPython console of the data frame with all the labeling and axis set, etc., one-to-one with the two lines. We want to plot from files very easily. Last time you saw only X, Y that we can create the curves, but it was very complicated. You have to provide X and Y and everything. Now it becomes much more easier. This here is an example which shows you how to create curves from a single file. I use here the wildcards all again. You can use a list, a sublist of this one, creating from the data file. And you see here, using this one, it's automatically created. This is exactly similar like if you go here and plot from create curves by file, and you see wildcards. And in addition, the layout, type, and organization are supported here. You see the type, this is this one, which you know from your GUI, which most of you most likely are familiar with. And then the layout, one plot per request, this bar here. So very compact one. And note the display options will come in 2024.1. They are currently not supported. For this one, when I run the script, I will switch to HWC and clear it, and that we see that also clear the console, that you see that not even when we run Python, that you also see that the logging hasn't turned off yet. You see the Python script runs, which you have seen, creates the plots, and this is the one-to-one match in HWC, also very compact. So this shows you how this goes hand in hand, running this Python snippet here. For multiple files, now you want to do for a DOE overlay, do the whole 9 yards. This, in addition to the create curves by file, you can also use the multiple file class, and this one creates a dictionary file set. So for the dictionary file set, you need at least a directory and the relative path list. And in addition, I can also have the layout settings, prefix, suffix, which here for directory level 2, etc., which can be used. And then you can plot it. And please be aware that the create curves by file, you use it exactly as you have done before, but now you can provide, instead of the file name, the object or the label of the file set, and then you will plot everything. I run the demo. Again, you will see here multiple files. And you see here HWC recording, very compact with a file and the relative file list. And this reflects exactly the code you see here in Python. Yes, so last but not least, before I switch to Dimitri, copy log to Python. This one is when you have holes in the current Python coverage, you want to use maybe a HWC. This is now very easily included. So you can log to Python. This is the history of some commands. And this one here is shown how the log file will be used. Please be aware that you can do it easily in the console, right mouse click, copy to Python, then the highlighted will be copied. And you can paste it in your script, or you log to Python and turn it on. And then the log file will be written in the work directory. You can please be sure that when you reuse the code, that always import your utilities. The handling of the directory where the log file is saved is, and the name, the mode, append, override is exactly the same, which you are maybe already used in TCL logging. That finished my part, and I hand over to Demetrius.
So I will speak to you about how you can support our Python initiative, how you can help us on create a database, a knowledge database on Altair community. In fact, we want you to ask questions on Python when it will be available on 24 version, on HyperWorks scripts and customization in Altair community, and also upload your scripts and extensions on Altair and Change. And the purpose of that is we want to encourage you to use our Python APIs and create a database that the users can find useful in how they can use the Python. APIs. And also, I'll talk you about a feature that will be available for the 24 release in Altair community. It will be a Notepad++ extension for Python APIs because Notepad++ is a popular editor and many users they use for scripting. So we created a template that combines the standard Python syntax with our new HyperMesh APIs. As you can see here, we can have a command of HyperMesh and have an auto-completion as an auto-completion and having its docstring. It is this Notepad++ extension supports the HyperMesh, HyperView, and HyperGraph clients. By this, we have most of the Python APIs for these clients. But as a disclaimer, the only requirement is for using this template is that the user need to follow the instance naming that we have in the XML file. The XML file is in the fact the way that puts the auto-completion and argument description of Python APIs inside the Notepad++. This XML file will be available in the community, as I said, in the next release. And let me show you a quick demo. This is the XML file that has all the commands and arguments. And if I go to Notepad++ and write, for example, import HM, import, as you see, we have auto-completion, HM entities as end. I create a model instance. You see here the arguments and model.translate mark, for example. You see the arguments here, collection, vector, and distance with their type. Thank you for hearing.